Hi guys, this is Mr. Urrego, and today we're solving exponential equations. How to solve exponential equations. The first one we have is 3 to the x equals 81. The idea is we have a power with a base of 3. The idea is to have the 81 as a base of 3 as well. So I need to break the 81 into 9 times 9, and each 9 is going to break into 3s. And I have 4 3s. All right, 1, 2, 3, 4, so it's 3 to the 4th. So I'll rewrite 81 as a 3 to the 4th power. And there's a property that says that 1-to-1 property, if the bases are the same, the exponents are the same. Therefore, x equals 4. And that's my final answer. Another equation with the same idea. Base 2, but I have 16. But if you notice, I have a 2 into the 16. Same as here, I break the 16 into 4 and 4. The idea is to get it in the same base as a power of 2. So 4 is 2 times 2, 2 times 2. So 16 is the same as 1, 2, 3, and 4, 2 to the 4th power. I have to replace that. So I have 2, 3x minus 8 equals, instead of the 16, I write 2 to the 4th power. And same property. My base is the same, the exponents are the same, therefore I have 3x minus 8, which is equal to 4. And from there I solve for x. Plus 8, and I have 3x equals to 12 divided by 3. My final answer is x equals 4. All right? So what we're doing right now is getting the same base on both sides of the equation. As soon as I have that, I make the exponents equal, and then I find the value of x. What about this one? 4 to the x equals 1 over square root of 2. Now, radicals, we get confused. What's the idea? Prime, right? 2 is a prime, 4 is not a prime, but I know that I have a 2 into the 4. So the idea is to have the same base on both sides. The 4, I can break it into 2 times 2, which is going to be, instead of the 2, I'm going to write, instead of the 4, I'm going to write 2 to the 2nd power. But I also have an x on the outside. So instead of the 4 is to the square, x on the outside. Square root of 2, I need to write that as a rational exponent, which means a fraction. So my exponent for that one is 1, and my index is 2. So that square root of 2, I'm going to write it as 1 over 2 to the 1 half. All right, so that square root of 2 is 1 half. Now I need to bring that to the top. So here I have a power of a power, 2 exponents. What do I do with them? Multiply them. So 2 times x is 2x. In the other side, that 2 to the 1 half that is on the denominator, I need to bring it to the top. Because I'm moving them to the top, the exponent becomes negative. Now my bases are the same. If the bases are the same, exponents are the same. Therefore, I have 2x equals to negative 1 half divided by 2, and here the whole thing divided by 2. Okay, this is a tricky one because you need to do the reciprocal. So 2's cancel, x equals negative 1 half over 2. Reciprocal is 1 half. Therefore, this is the same as having x equals negative 1 half times the reciprocal of the denominator, which is 1 half. Negative 1 half times 1 half is negative 1 over 4. So it's a tricky one because it has a radical. All right, let's try another one. Okay, now we have this exponential equation, 27 and 9. None of them are prime numbers. The idea is to get a prime number. So 27 is the same as 3 times 3 times 3, which is 3 cubed. So instead of the 27, I'm going to write 3 to the 3rd power, but it's also an exponent on the outside. So I put this in parentheses, and now I'm going to have an x plus 3 on the outside. The other side, 9 is the same as 3 times 3, which is 3 squared. But again, I have an exponent on the outside, which is x minus 1. All right, what do I do when I have 2 powers, 2 exponents? I multiply them. So, well, hold on. I have the same base. Let's multiply the exponents, and then we keep going. So I have 3 to the 3 times x is 3x. 3 times 3 is 9. The other side, 2 times x is 2x. 2 times negative 1 is negative 2. Same base, exponents are equal. So I'll bring exponents, which is 3x plus 9 equals 2x minus 2. From there, solve for x. That turns into easy. So minus 2x, I have x plus 9 equals negative 2. Last step is minus 9 cancels. Negative 2 minus 9, negative 11. Okay? Now, every time we get an answer, we want to double check our answers. All right, let's get used to that. Double check our answers. So I go to my original problem. I have 27 negative 11 plus 3 equals 9 negative 11 minus 1. And right now I'm checking my answers. 27 is 3 cubed. Negative 11 plus 3, negative 8. 9, 3 squared. Negative 11 minus 1, negative 12. Exponents, multiply them. 3 times negative 8, negative 24. 2 times negative 12 is negative 24. And 3 to the negative 24 is the same as 3 to the negative 24. Therefore, my answer was negative 11. Okay? We need to double check because some of these equations will have extraneous solutions. Now I have to solve this equation. 40 e to the 0.6x minus 3 equals 237. The idea is to solve for x. So because I have an exponent that is a variable, I need to isolate that part. So I got to get rid of that negative 3 and then the 40. First thing I do is I add 3 on both sides. I'm going to have 40 e to the 0.6x, the 3's cancel, equals to 240. Divide by 40, divide by 40, the 40's cancel, and I have e to the 0.6x equals 0, 0, 24 divided by 4 is 6. Now my exponent has the variable. I need to leave it by itself. So what's going to happen with this? I need to use the inverse property. And now, what's the inverse of e? ln. That's right. ln on both sides. So I apply ln on both sides, the inverse property. What's going to happen here? The ln is going to cancel the e, and my 0.6x drops. And on the other side now I have ln of 6. From here, leave the x by itself. Divide by 0.6, divide by 0.6, and my final answer is ln of 6 divided by 0.6. And this is a valid answer. Or you put it in the calculator and you round it to 3 or 4 decimal places for the most part. All right? Now I have this type of equations. All right? The other ones, we're making the bases equal. So we can get the exponents the same. Now in this case, I have 2 to the x equals 5. 2, 5, different bases. Nothing that we can do. But now we apply the inverse property. Okay? And there's two ways how to do this problem. One way is the inverse of base 2 is use log on base 2 on both sides. Log on base 2, right? That's the inverse. Why? Because the log on base 2 of 2 is going to cancel out and my x will drop. And in the other side I have log on base 2 of 5. Once I have this, because they have different base and argument, then I have to use change of base. So my final answer would be log on base 10 of the top, which is 5, over log on base 10 of my denominator. And then you plug this into the calculator, you get an answer. Round to 3, 4 decimal places. You can also use ln of the argument over ln of my base. And that's how you do change of base. This is one way. What's the other way? You have 2 to the x equals 5. All right? Instead of applying log of base 2, right, because I want to cancel this 2, I just apply either log base 10 or ln. ln on both sides. All right? And by doing this, because these are one-to-one functions, by doing this, what's going to happen is now I can play with those properties of logarithms. I have an exponent. That exponent comes in the beginning, in the front of my function. So therefore I have x ln of 2 equals ln of 5. And from here I can find the value of x. I want to cancel ln of 2, so I have to divide ln of 2 on both sides. oops, ln of 2 on both sides. Ln of 2 divided by that gives me x. And if you notice, look at this answer. It's the same as that answer. Therefore, ln of 5 over ln of 2, and that's a valid answer. Put in the calculator, 3-4 decimal places, and that's your final answer. Let's practice one more of this type. Okay, so something similar. If you notice, I have a power 3 to the x equals 5, different bases, nothing that I can do. I have an 8 though. All right, this 8 is multiplying the power, so I can get rid of that as my first step. Divided by 8, divided by 8, and I'll have 8's cancel. 3 to the x equals to 5 over 8. But my variable is my exponent. Therefore, I need to drop that. How can I drop it? Easy, straightforward. ln or log base 10. Either one of them, because you can use this in your calculator, and that's the idea, applying natural log on both sides. Once I have that, remember, my exponent is going to drop in front of my function, so I have x times ln of 3, and the other side I have ln of 5 over 8. And now my x is not an exponent anymore, therefore I can leave it by itself. Last step, divided by ln of 3, ln of 3, this cancels. My final answer is going to give me ln of 5 over 8 divided by ln of 3. And you can plug this into your calculator. Again, you can use either ln or log base 10. Either one of them will give you the same answer. Now let's work in something like this. If you notice, my exponents are becoming bigger and bigger. That's the idea, so getting more complicated. But different base, okay? Different base. So what's the idea? Apply, okay? Either apply natural log or log on base 10. So the easy one is to apply natural log. ln on both sides, okay? So what's the idea about this? Is so we can drop the exponent. That's the whole idea about applying natural log on both sides. And remember, that's the one-to-one property, okay? We're applying one-to-one property. Exponent drops in the beginning. Exponent drops in the beginning. So we'll have x minus 2 ln of 5. And the other side, 3x plus 2 ln of 3. But now what? If you notice, I have x on the left, x on the right side. So now we got to do a little bit of algebra. In my case, I have to distribute this with the x and distribute with the -2. So my ln was going to multiply each one of them. So the first one that I have, will have x multiply ln of 5 minus 2 ln of 5. And that's my left side. The other side, the same idea. ln will multiply the 3x and the 2. So I have 3x ln of 3 plus 2 ln of 3. Now what? I still have x on the left side, x on the right side. Because I have x on both sides, I need to bring them on one side. And then I do greatest common factor, and that's that kind of the trick that will make my x's together into 1. So let's bring this 3x on the side. 3x ln of 3 minus 3x ln of 3. Okay? So I have x ln of 5 minus 3x ln of 3 minus 2 ln of 5, and that's equal to, this cancels, 2 ln of 3. Same idea. I have my x's on this side. Let's get rid of that to the other side. So I'm going to add plus 2 ln of 5 on both sides. So what I have is x ln of 5 minus 3x ln of 3 cancels, equals 2 ln of 3 plus 2 ln of 5. All right, and we're almost there. Now what? X is here, x is there. I got to do a greatest common factor of x because I need only one x. So take x as a common factor. So x is a common factor. What goes inside? This divided by this gives me ln of 5 minus 3, the x's cancel, ln of 3, and close. And now I need space. Let's get rid of this. So now that's going to be equal to 2 ln of 3 plus 2 ln of 5. And if you notice, the x common factor, and I get two terms, but now my x is by itself. So the last step is just to leave the x by itself, which basically is canceling this ln of 5 minus 3 ln of 3. Whatever I do on one side, I do on the other side. Ln of 5 minus 3 ln of 3. And that's how we make this trick greatest common factor, so we can get rid of this, and now it's on the other side. So my final answer, x equals 2 ln of 3 plus 2 ln of 5, everything divided by ln of 5, ln, right, minus 3 ln of 3, and this is my final answer. Guys, thank you for watching. Make sure you subscribe to the channel, like the video. All right, stay tuned. Take care. Bye-bye.